So this question has been asked in NIMCET 2009. I'll read it out for you. The switching expression corresponding to this Boolean function f of a, b, c, d equal to sigma of 1, 4, 5, 9, 11, 12 is, and we are given with 4 options. So now there are 2 ways we can solve this. One is to use normal Boolean algebra laws, and the other is to go for the K-map approach. Now what I would suggest is the K-map approach would be a lot faster and a lot easier as well. Boolean algebra laws would make things a lot more complex because you would have to go through a number of steps, and then a lot of it depends on intuition. But then a Karnaugh Map will provide you a concrete solution, or let's say it will provide you a concrete path leading to the solution. Now, as we all know that Karnaugh maps can be taken up for 2 types of expressions. One is sum of products and the other is product of sums. Now, which expression does this function represent? This function represents a sum of products expression, and how can we make that out? We can make that out using this summation symbol. Okay, so without wasting any further time, let's go ahead with the solution. Now I'll construct a K-map. What I'll do is, I'll just, due to lack of space, I'll simply erase the options, and let's see what it comes out to be. So I hope you have noted down the question. What you could do is you could rewind the video if you haven't, pause it for a moment and then note it down. So first you construct the grid for a K-map. Now, since it is a function of 4 Boolean variables, we'll have 2 to the power of 4, that is 16 cells. So we'll have 4 rows. We have 4 rows here. And now as we all know, K-maps follow gray code. That's why it is 0, 0, 0, 1, 1, 0, 1, 1. As you can notice, every consecutive combination is differing by 1 bit. That means 0, 0 and 0, 1. There is a change in 1 bit. 0, 1 and 1, 1. There is a change in 1 bit. 1, 1 and 1, 0. There is a change in 1 bit. Similarly, we write it here as well. 0, 1, 1, 0 and 1, 1. C prime D, C D, C D prime. A prime, B prime, A prime B, A B, A B prime. A completely labeled K-map will make simplification a lot faster. So you might be thinking that constructing this K-map is taking up a lot of time, but this complete construction will enable us to get to the solution a lot faster. So now what we do is, we see the values given to us, and corresponding to those cells, corresponding to those numbered cells, we place 1. Why do we place 1? Because we are dealing with sum of products, and sum of products is represented using 1. Product of sum, mind you, is represented using 0. So in the cell 1, I put a 1. In the cell 4, I put a 1. 5, 1. 9, 1. 11, 1. 12, 1. Okay. So now I have all my minterms here. And now what I need to do is I need to group them in such a way that my expression is minimum. Now what you can do is you can make out from the options that every option there are 3 terms. Now if there are 3 terms, it probably means that we'll get 3 pairs. Now if you have been able to make that out, then you can understand that these 3 pairs would lead to the simplest of solutions without any redundancy. And now how do I write the final expression for these 3 pairs? Now look at this. Let me write it for this pair first. Now see, for this pair, first look at the rows which are making up this pair. These two rows are making up this pair. Now, in these two rows, the variable that is changing is A. See, A complement is changing to A. So, it will get cancelled. We are left with B. So, I write B. Now, again, for this pair, see the columns that are affected. Only one column is affected, that is C prime, D prime. See, these two ones that are making up this pair are present in only one column, are present across one column, that is C prime, D prime. So, we directly write C prime, D prime. In the same way, we solve it for the other pairs as well. Now, see, the only row that is making up this pair is this one, A, B prime. So, I write A, B prime, there is no change. So, I have to write the entire thing. And now, the columns that are making up this pair is C prime D and C D. Now, which variable is changing? C is changing. C is changing from C prime to C. So, we are left with D. So, I write D. And finally, for this pair, what I see is, these two rows are making up the pair. Here, A prime remains constant. B is changing. So, I write, wait, have I done this? No, I haven't. Yeah. So, B is changing. So, A prime remains. So, A prime remains. I'm talking about this pair. So, A prime remains and the column that is constant is C prime D. C prime D. So, this is our final expression. So, F of A, B, C, D comes out to be, the simplified expression comes out to be this. And if you look at the options, then this is option A. Okay, I hope you have understood the solution. Thank you.